Okay, so let's get through this. Oh my goodness. Okay, so number 6.
Quiet class.
They have, we've done a couple of them like this before. You got a little box made for you, something like that. And you are trying to find the length of the longest diagonal from this corner, back corner to there. And you know, because they tell you, that this side over here is 15. This side, back side is 20. And the height is 20 as well. And so what you got to do is you have to figure out the length of that diagonal right there using this right triangle. So you know that side's 15 and this side is going to also be 20. So if you go 15 squared plus 20 squared and then take the square root, what do you get for that diagonal? 25, because that is a version of the old 3, 4, 5 right triangle, right? This is 3 times 5, this is 4 times 5, so this is going to be 5 times 5. Now we need to use this triangle right here to find the answer that we're looking for. So I need to go 20 squared plus 25 squared equals the diagonal squared. So 400 plus 625 equals the diagonal squared. Add them together.
Don't make that voice.
Take the square root, and what do you get? It's 30 point something? Yeah. What?
5 times square root of 41.
Well, you just made that up.
No, I did not. I tried it.
Okay, 32.01. Okay, which Zola says all the answers are given with these weird square roots in them.
Not all of them. Just
Not all of them, you're right. 3 of them are. And so you need to figure out which one of those comes closest to the answer that you got. And it turns out that it is 5 times the square root of 41, which is answer choice B. Okay? All right, number 7.
How about me?
We skipped the density stuff. You don't really have to worry about this, but I just thought, oh, what the heck, you can give it a try. Density, I'm sure you know from your science class, is mass divided by volume. So the scientists found this clump of metal on their floor, they weigh it, and they figure out its mass is 702.8 grams.
Come back to the box.
And then they need to be able to divide it by the volume to figure out its density. So the question is, if you have this irregularly shaped chunk of metal, how can you measure the volume? And the easy way to measure volume is to put it in water, and then you can measure the amount of water that is displaced by it when you put it in there, and then that is going to equal the volume of the thing that you put in. So in other words, when you get into the bathtub, the water level on the bathtub rises by the same amount as your own volume. Does that make sense? At least without your head, unless you go all the way under, which would just be weird. So it's a cylindrical container. The water rises 2.2 centimeters. And so that's the height that you're going to use for the cylinder, because we're only worried about the amount of water that's been displaced. The radius is 3.
The top of your head, right?
Shh. We're recording. So the formula for the volume of a cylinder is pi r squared h. Does anybody have written down what that came out to be? 9 times 2.2 is going to be around 20. It's going to be around
62.26.
62.26 will work for me. So to find out the density, you go the mass divided by the volume, and you come up with an answer of around 11.3, which means, unfortunately, for the scientists, what did they find on their floor?
Lead.
Just a clump of lead. It would have been cooler if it was gold. So that is also B. Yeah, that might be an easier way, but maybe maybe you need to watch the Maltese Falcon, and then you'll know. Okay, number 8 is a simple proportion. 1 over 1 equals 1 over what? 18 over 38 equals 12 over x. Cross both line divide, and you get that x equals 25.3 repeating, which is also 25 and a third, which is also answer choice B. Now, you could also have done this. Some people did it by going 18 over the length of this whole entire side. 56 equals 12 over the length of the whole side, which would be 12 plus x. So you can do it that way, and you'll come up with the same answer if you do. Okay? Yes, Richard, you will. Math works. Okay, so the first three, the answer was B. Now we've got a little sine, cosine, tangent review. If you want to find the value of x, x is the what side of that triangle? Hypotenuse. 18 is the opposite. Which trig function uses opposite and hypotenuse? Sine. So the sine of 21 degrees equals the opposite side divided by the hypotenuse. Since the thing is on the bottom, do we multiply or divide? We divide. So x is going to equal 18 divided by the sine of 21 degrees, which I believe is answer choice A. All right, if you got number 10 wrong, don't feel bad about it, because we didn't spend a lot of time on these properties. So I'll just tell you the answer to this. If A equals B and B equals C, then you know, of course, that A equals C, right?
Yeah.
If I'm as good at basketball as Tucker, and Tucker's as good at basketball as Shad, then obviously Shad and I are the same at basketball as well. That is called the transitive property. And the reason it's called that is because it's sort of the A gets transferred all the way across to the C. Okay. 11, we took either theorem or conjecture. I'm not sure which one they're looking for there. Number 12, which point of concurrency is equidistant from the three vertices of a triangle?
D. Oh, wait, no, that's the wrong answer. I put a star.
If you are going to be equidistant from the three vertices of a triangle, then that means that you're going to be able to draw a circle that goes around, that hits all three of those points. Okay? Roughly something like that. The circle is going around the outside of the triangle, which we say means it is circumscribed around the outside of the triangle. So the point that you are looking for would be the circumcenter. That is the middle of the circle that goes all the way around. A lot of you put in center. That would be the center of the circle that fits inside the triangle.
What's the centroid?
Okay? The centroid, I don't know, what's the centroid?
I don't know, that's what I put.
Is that the center of balance of the circle? Okay, that's the center of balance of the circle.
Yeah, circle the same thing, right? Of the circle?
Oh, no, because there's more over here than there. It doesn't work out that way. The centroid would be somewhere more towards the middle.
Of the triangle.
Right, of the
Okay, you said
triangle.
circle.
Oh, I'm sorry, I misspoke. All right, number 13. I don't know if anybody got this one right. So it's possible that I got it wrong. It says AD is parallel to BC. So these two lines are parallel. And CD is congruent to AB. From this information, which of the following reasons could you use to prove that the two triangles are congruent? Well, if these two lines are parallel, then that means that this angle is congruent to that angle because of Y. Alternate interior angles, parallel lines are congruent. You also would then know that this side would be congruent to itself. Okay? Yes? Yeah. I think it's a situation where it is always going to come out to be congruent, but with the given information, we can't necessarily say that it is. because the angle that we know is not in between the two sides that we are given. So we have a side-to-side angle situation, which is not one of the things that we were ever able to use to prove congruency. Did I get it wrong?
No.
Oh,
Well,
What's
some
that?
of the other angles congruent too.
How do you know that, though?
Because that's the
Oh, good reason, because that's the good.
But it makes sense.
I know, it seems like it's probably going to be right, but from what they have given us, I don't know that we. So it's none of the above. I don't like it either. Okay, then this one right here, we want to find the measure of angle GHI. So we're trying to find the measure of this little angle right here. If this is a parallelogram, what do you know is true about this angle and this entire angle right there? They're supplementary, they add up to 180 degrees. The other way that you could do it is you could say if this is 103, just like on the last problem, this is going to be an alternate interior angle, so it's also going to be 103. No matter how you slice it, these three angles need to add up to 180 degrees. So if I subtract 103 and subtract 56, I am left with 21 degrees. All right?
Yeah.
Okay? And so the answer we're looking for is C. And finally, number 15. What's the surface area of a sphere with a radius of 3 centimeters? They will give you all of these formulas that you need on the test, so you don't need to worry about memorizing them. But the surface area formula, anybody know it? 4 pi r squared. Very good. So if I plug in r as 3 squared is 9. 9 times 4 is 36. So my final answer is 36 pi squared centimeters.
Can you give us a paper with formulas on it when we practice test?
Tomorrow, or tomorrow, yeah. Yes, I can do that, okay? All right, and then party, I made you suffer through some of those, but let's not worry about it. Let's not party.